In order to do our calculations using RiskMaster, we first need to do a set of standard 2D hydraulic calculations on our model, which has had the new damage receptors added to it. So let's have a quick look and remind ourselves as to how we conduct a hydraulic simulation within InfoWorks ICM. Let's start by dragging out the standard schedule dialog box. This allows us to define the network that we're going to be using, allows us to define any rainfall that we're going to be using, and all other associated items that are going to be used for the simulation. The dialog box doesn't change for RiskMaster. There are no additional items of data, simply your risk model, your rainfall that you're going to be using, plus any other time-varying inputs. And all we need to do is to rerun or run for the first time, depending on which way around it is, your simulation. I want to show you this live, so we're going to take our model and we're actually going to run it through on the network so you can see it happening. My computer is connected to a work group, so I could do the hydraulic simulations on my computer, but I've got a series of servers that are available, and we are going to be doing a series of different hydraulic runs with different return periods from 5 years up to 100 years. So rather than load up all those simulations onto one machine, I'm going to spread it across the 3 different servers that I have available to me. We can have a look at that process by looking at the dialog that we have here, and you can see that the software is going to start by pre-processing the network that we have at the moment, and then with the pre-processing done, the simulations will be uploaded and pushed across to the various servers that are available within the workgroup itself. So we just need to wait for that process to both start and complete, and you can see the pre-processing is going on very quickly now, and once each model has been pre-processed, it is uploaded to the work group, and the 3 simulation servers that are available immediately start going on doing those runs. You can see the names of the machines in the dialog, so we can see they've got the names Goyle and Crab and Lobster. So they're the 3 servers that are available in my work group, and as soon as one simulation finishes on any particular machine, the results are downloaded back to the laptop that I'm using here at the moment. You can see it saying downloading. That happens very quickly. And eventually all the runs finish. Now the hydraulic results that are being produced are identical to any standard 2D hydraulic run. The only extra items of data are for the damage receptors themselves, where we will have the actual 2D depth created, which will be used for our risk analysis in just a moment. So those runs have all finished, and they've all been done. And what we can now do is to go to the final stage of that risk analysis, which is to actually take those 2D results that have been created and create a lookup from the 2D depth against the damage curve in order to come up with a financial value of damage and a subsequent value of risk. That type of analysis is done as a secondary simulation, a post-processing, if you like, of the 2D results. We create a brand new risk analysis item on the tree. You can see it here, and within that tree it has a dialog which is very similar to the run schedule dialog that we saw just a moment ago. Here we give our run a title. We drag in that damage function that we created earlier. So we drag in the damage function into this particular box, and here we drag in our result that we just created, or results that we've just created. And we can simply now tell the software to do this post-processing analysis to combine our 2D results against our damage function. So if I hit rerun on that particular item, in this case I'm going to do it on my laptop, do it on this computer here rather than outsourcing it to one of the workgroup computers. And we'll get another line appearing at the bottom of our task list showing us what's going on. So the start of the process is to initialize everything up and then do the calculations themselves. Now you can see in the list above the damage calculations that are currently going on that we did a series of 5 different simulations, and they, as I said, were with different return period storms, from the 5-year return period event through to the 100-year return period, and in each case we had a 60-minute duration for each of those storms. And that risk analysis has already completed, and the results are available to me on my computer here and now. So let's have a look at how we look at those risk results. Well, the first thing that we do is to drag out our simulation, and we could either drag out a simulation from the list here, or if you already had a workspace available, then it may well be simpler to just take the workspace and drag the workspace out, and that will give us our predefined view and put our network model and results within that predefined view. And here is the model that we had earlier. We can have a look at here. We're on the over towards the right hand side of the model, but we could also, if we wanted to, pan across and come back to the area where we were looking earlier. And you can see here, if we zoom in a little bit, we can see all the flooding in the roadway, and we can see the various buildings. And now we can also see that the various buildings have got different colors associated with them. And this is where the risk analysis has been come into its own. Not only are we looking at hydraulic results, but we're also looking at the actual risk results. And we've got different colors on our various properties to represent the actual risk return period, the return period that creates that risk in the first place. So if we pop up the key and have a quick look at what's going on here, the different colored houses are based on the return period that caused the first occurrence of flooding in that particular area. So in this particular case, any houses that are either purple or blue will go with the lower return period storms, whereas with the higher return period storms like the 50-year and the 100-year, they will have the orangey colour and the dark purple colour. So we can see what's going on. And in our particular case, our house that we were working on, you can see that house is susceptible to the 50-year storm in this particular case. So we've got all of that information available. Now, obviously, we're looking at it there from a very graphical viewpoint, but we can also go to our risk analysis run that we've just done and actually pick up any of the information that we want. So we can bring out the analysis, and here we've got just the summary table that we've put up. First of all, summarizing the information that we have, and then you can see, if I just go down the list very slightly, for each one of the receptors that we have, this is the first receptor in my list, you can see the return period down the side here in this column, the probability of that particular event occurring in the column next to it, the damage associated with that particular return period. We multiply the event probability with the damage for that 60-minute event, and we come up with an annual damage value based on the 5-year event. If we then sum all of the different return period storms, as our return period gets larger in size, our event probability will obviously drop, so that will tend towards 0. And although the actual value here may be larger, the subsequent values, of course, smaller. And then that gives us then, at the end of that summation value, an expected annual damage value, or EAD. And we can see the expected annual damage value for this particular receptor or this particular building. Going a bit further down the list, in fact, if we go all the way almost to the bottom of the list, we are looking at the various components that are done. And in this case, we can now go for the codes that are associated with particular types of property. So in this case, all of our terraced properties, again for the 5-year through to 10-year return period, 60-minute storm, the annual damages and the expected annual damage based on summing all of those items. And we can see got an analysis for our terraced houses or for our local church. And then finally, at the bottom of the list, if we just go down one further step past all of our shops and our schools, we can have the total damages over all of the different receptors, again for our different return period storms. And then finally, for every single property type, a table looking at the return period and the expected actual depths. So these are the 2D results. These are the 2D depths that were created in this particular property for each one of those storms return periods that we can see there. And that is tabularized through the whole thing. Now that tabular data is what we are essentially then able to show on any one of these particular properties. So if we took our property tool here and clicked onto our house that we were particularly interested in and working with, which was our porous polygon, we can have a look at all of those values that we had for those depths in that particular property. So we can see for the first 3 storms, first 3 return periods, there was no depth of water, so no damage was caused. But then at the 50-year event, we started to get damage, and obviously again for the 100-year event, and we're using the user text field to do a lookup on those numbers and surmise that the critical return period in this particular case is the 50-year event. And we have also all the actual damage values, the actual financial values of damage which were reported in those tables. Now those tables obviously can be looked at on the screen as we saw now, but they can also be exported to CSV files, and that means they can either be brought back into InfoWorks or indeed put out to any other third-party application. And we can export the data that we looked at either for the individual damage receptors or for the components within that receptor. So that might be buildings with basements against buildings without basements. We can look at the various damage codes. So that's looking at terraces against semi-detached houses, against bungalows, against flats. Or we can export the actual inundation depths, which were the numbers we looked at just now and which we can see on the screen in the graphical view. So that just gives you an idea of the different types of view that can be created with RiskMaster, both in terms of graphical presentation and also in terms of tabular outputs from the risk analysis. And that concludes the presentation of InfoWorks ICM RiskMaster, where we can look at not only our hydraulic results and depths of inundation, but also the resulting damage that may be caused by those depths of inundation and the associated risk the properties may be at.